Ahoy there, captains, and welcome to this Lunch and Learn together with Dick van Veen and Rick van Akkeren from BAM. It's actually heavy duty infrastructure solutions. What is it exactly, Dick?
Yeah, we call ourselves heavy duty charging and electrification. So we're involved in the infrastructure activities which relates to heavy duty transport by rail, by waterways, or by road in the near future with the heavy duty trucks.
And if you explain it like that, it's way less sexy than what you are actually going to do in Amsterdam.
Thank you for that.
No, I mean, the project that you're going to do with BAM is probably one of the sexiest shore power projects I've ever heard of. It's one of the biggest shore power connections, at least in the Netherlands, but worldwide. It's also quite large and in the heart of the historic city of Amsterdam. So there's also a lot of challenges involved there. And I've been told, Dick and I, we know each other from another large shore power project. And Rick, I've been told by Dick that you are the brains behind the project. So I'm going to leave the word to you to present about the shore power project in Amsterdam. Beautiful.
Okay. Well, thank you, audience. Thank you for being here and spending your lunchtime to learn a bit of what we're gonna achieve at the cruise terminal in Amsterdam. In the screen you see the port of Amsterdam, dating around 1300, when all ships just sail in the city. Port of Amsterdam has been a port for a long time. It created more or less Amsterdam and gave it all the world. So it's very nice for us now to be involved in a project like this. There's also an old picture. This is where it will happen. The presentation of today is about shore power for the cruise terminal. This is actually a picture of the cruise terminal. Well, at that time it wasn't a cruise terminal, but Piet Heinkade back in 1950. And during our presentation, Rick will explain on this. We still face some challenges out of this time frame. Because the quay wall, which you see here, it developed immense. So here you see the cruise terminal as it is now. It's physically exactly the same location, and a lot of all the older building and quay wall constructions are underneath what you now see. So we will come back on that later on with some nice drawing. We will face some challenges. Before that, just a short introduction. I, and together with my colleague Rick, we will take over at certain time of this presentation. We are both active in the field of what we call heavy duty charging and electrification. So our main activities is to construct the underlying electrical infrastructure which is needed to have the trains running, the buses driving, in the near future all the electric heavy trucking, and also shore power. And we hope to achieve where all these sectors are now more or less independent and have their own planning and time frame. I think we have the knowledge to combine these kind of infrastructure. So to combine the railway electrical infrastructure or to make use of it to charge heavy duty trucks, or maybe even to supply at certain times shore power for container vessels, for instance, at the Maasvlakte in Rotterdam. There is a train which has its own power supply. The train only drives one time in the 5-6 minutes. It doesn't drive in the night, so you can perfectly make use of that. That is why we entered this business. Our activity started in the rail, and now we're active in other markets. So that's a bit why BAM is also entering the shore power market, which we did quite successful. There was a tender on the market, as you probably all know, for Cruise Terminal Amsterdam, and it all started more or less with this drawing, which you see here on the screen. And our presentation will primarily go around the energy hub. This is the BAM scope. We earned the tender together with the Danish company Powercon. They will take care of the actual shore power system, but we as BAM, we will take care of all the primary energy installations, but also the building, the piling, all the cable works which needs to be done. Interesting aspect of the choices the Port of Amsterdam made is that they will not only develop or not only build and power systems which will solely be used for cruise vessels, seagoing cruise vessels, but also river cruises. But they are also, although it seems like a small part in the energy hub, we prepare ourselves to have batteries included. We prepare ourselves to have to create a charging hub or a mobility hub. When a cruise vessel sails in, a lot of coaches, buses will take up the passengers. In the near future, they all should be electric. So already at this moment, we make sure that we have enough power available, but also we prepare all the technical installations to make that happen. And it is even in the ambition of the Port of Amsterdam to have this power available for instance, taxis or public transport, if needed. So to really contribute to the energy challenges and the energy transition in the crowded area of the city of Amsterdam. So this is where it started, and this is an overview how it should end. This is an artist impression of what we can now realize on the Piet Heinkade. So the energy hub I just thought about will be within this building, which needs to fit in the environment, and of course it needs to fit in the really limited space. This area is roughly 30 meters by 12 meters. I think the image is a bit stretched out, so it's not really in perspective, but this is how it should look like underneath an hotel, which gives some challenges, and it needs to be built in a crowded area, especially when the cruise vessels sails in. So the shop stays open as we need to perform the work. And from here, I'd like to hand over the presentation to my colleague Rick. Rick was tender manager in this process, and he took care of all the coordinating activities of the design and the electrical installations, project management, etc. Rick, can you take over? And
Yes. Thank you, Dick, for the introduction.
Give me a hint when I needs to move on to the next slide.
Yeah, exactly. Well, this is a fine slide to start with. As you mentioned, we already made this 3D design model during the tender phase to see what kind of issues we have during construction and realization of this building. which you can see here is one of the one of the main issues for construction, is the existence of the concourse and the shores which cut through our building. We also have to build on a quay which is built in 1860 on wooden poles. No drawings are no good. This is a drawing from the existing quayside. The quay is actually built in 3 parts. So the oldest part is from 1860. Then they build a new part on it in 1960, I think, or 1950. And the latest part is the jetty part above the water on steel poles. That's built in 2007. So we have different structures. We have different sets of drawings. There's also some kind of railway for the cranes underneath the ground. And between all those structures, we have to make 24 poles for the foundation of our building, as you can see here. The left side is the water. You can see the boulders where the ship's moors, and further to the right is the quay side. So part of the quay is above the water, and a part is just founded on the ground. So that's one of the main challenges we face in this project. Although my civil colleagues really love this, and they are really looking forward to build it. And one of the other challenges, as Dick said, is the existence of the hotel and the presence of all the trucks and baggage handling activities on the quay side. So the building actually houses all the equipment needed for the sea cruise and river cruise. This is actually what is inside. At the left-hand side, you see 8 containers, which contains the, as we call it, the onshore power system for sea cruise. That system will convert the voltage and the frequency to the needed voltage and frequency for the cruise vessel. That is 6.6 or 11 kV and 50 or 60 hertz. Also, we built in some several securities to make sure that we can operate this system in a safe manner. Somewhere in the middle, you see the big 50 kV transformer. As Dick already mentioned, we not only fed the cruise vessels, but also the river cruise and in the near future, coaches and batteries. So that's quite a large transformer. It's about 30 MVA, which is directly connected to the grid of the Leander. In between that, we have several smaller transformers for the river cruise, some MV switchgear. We have at the right side, we have a room for the Leander switchgear. And one of the challenges here was that it has all to be in one building, and also the dimensions of the building were restricted by the Port of Amsterdam due to physical constraints, but also due to the requirements which the authorities set on this building, the Welstandscommissie in Dutch. This is layout, the technical layout. I think I already described it a little bit. What you can see here is how full the building is, and in this image we don't even draw the utilities like the ventilation or the HVAC, so that will also add up. What is interesting here is that there is a escape route between the hotel and the building underneath. So we have to take into account that people from the hotel, but also from the building, can escape in case of an emergency, and they also can escape. In the top of the building, we also have the escape route. You can also see several stairs. So we have also a multi-floor layout. So the containers are not 4, but there are 8, and also the Leander rooms are elevated from the ground level to house all the needed equipment. So they came in. Leander came in with 50 kV. We transform it to 10 kV, and from that we go to low voltage for river cruise, and as I said earlier, to 6.6 or 11 kV for the sea cruise. This image we already talked about. Then on the quay side, we have also a lot of cabling to do. At the left, you see the energy hub. As you can see, it's quite small, and that gives a little bit an idea of how large the quayside itself is. So we have in total on this image 4 sockets for sea cruise. Those are the blue dots at the top of the jetty part with the letter C marked. And we have a total of 8 sockets for river cruise. And of course, every socket has to be connected in somehow to the energy hub. And those are not just single cables. Those are really large cables with parallel connections. So to give you an idea, every river cruise cabinet has a 2 times 400 ampere connection available, and the river cruise is 16 MVA. So that's a quite amount of amps going through those cables. Those squares. That's also this image. During tender phase, we investigated what's needed to put in all the cables in the ground. Well, as you can see here, all those little squares are remarks for underground structures. So there are concrete walls. We have to drill through the quaysides. There are existing cables and pipes in the ground, high voltage, low voltage, and water and gas pipes. And we have to work our way around it.
And we have, like, to add on, what is shown, it's rather small, but we also have to work underneath the quay wall. So
exactly.
All these cablings, which is needed here, must be. We know what to do, but it will take some time.
Yeah, of course. Yeah, so we have to drill holes through the quay wall. You can see there on the left image, and then with cable trays underneath the jetty part. We have to bring all the cables to the end of the jetty and connect them to the walls of the shore power cabinets, which are a total of 12. Also here is the challenge during realization that during wintertime and summertime, also river cruise and sea cruise vessels moors. So we have to find a good spot and a good time to realize this while all the ships are coming and going, which is a really challenge for our safety officers. But we'll figure that out, of course. Just to give you a few insight in the complexity also on the quay side. This is the Piet Heinkade, as Dick already explained, with also some work to do at the Ruiterkade Oost, which is a couple of 100 meters to the left of the Piet Heinkade. There are 6 shore power cabinets for river cruise created with the same specifications. The existing quay is renewed by the authorities right now, and we are asked to also install those cabinets there. That means that they're probably going to be a 10 kV cable from the Piet Heinkade to the Ruiterkade through the I channel, and then we will convert it to low voltage and bring it to the ships. It's also part of this project.
Yeah, maybe like to add on that, we will make use of over 20 kilometers of cabling to have this project done.
Yeah, low voltage cabling. Yeah, exactly.
Big numbers.
Yeah, and that on a quay side, that's about 300 meters long. So you can imagine a little bit how much cables in parallel that is. The final slide, and then I'm gonna hand it over to Dick again. The left side, you see the 50 kV cable coming from Leander. They are going to connect it at the station Paverweg. And they have to make, I think, about a cable route of 8 kilometers to go to the energy hub, which also crosses the I channel through the tunnel. And also this involves a lot of investigation and communication with all these stakeholders here as they're going through a lot of, neighborhoods, woonwijken, and crossing the I channel, of course. So also for Leander, this is a big challenge.
Yeah.
You're going to talk further about it?
No, maybe this is the final slide. So we hope you get a clear overview of all the work, what needs to be done. We didn't want to talk too much about the why and how of shore power, but really do a deep dive in the work, especially for this projects to be done. In the project, besides the availability, the timely availability of the cable connection, the grid connection from the owner, we face some special issues in the city center of Amsterdam. One of the reasons to make use of shore power is beside the lowering of the emissions is also the sound issue. But it should not be the case when we limit the sound of the cruise vessel itself, that we have a high sound level of our system. So that gives quite a challenge. A transformer of this size makes a lot of noise. So we take all kind of measures to lower that noise, but we also will make use of water cooling in the A to reduce the sound of ventilators and that kind of stuff. And that relates also to the hotel. Of course, we don't want to disturb the guest in the hotel. Like many other projects in the Netherlands, we face the nitrogen issue, so we must limit the pollution during construction as much as possible. We will make use of as many as possible electrified equipment, building equipment. We have already quite a lot at BAM, and every now and then, and that is new for us in this context, but we are used to that kind of activities for working for the railways. But every now and then we could not enter our building site due to connecting vessels, logistic material, but also every now and then the site will be a custom area, so you are not allowed to enter the area without a passport, etc., etc. But to summarize, an interesting project. I will end the presentation. We're very happy. I hope I end. There it is. We're very happy that we may realize and could realize this installation at the site. Interesting area, a lot of big involvement of the city of Amsterdam, great involvement of the port authorities itself. We love to work with the guys from Powercon who really did a good job in this project. It was really a partnership, and I think that's the way how you should contract and build these kind of projects. So hopefully it gives some insight.
Thanks, Dick. Honestly, I'm going to book a few stays in the Movenpick Hotel when you're building this stuff. It's it's amazing
you
to
have
see.
A nice view.
Yeah.
Don't complain about noise or any other hindrance.
Yeah, I won't complain. No.
Yeah.
No, honestly.
And it needs to be. The system needs to be ready before Sail Amsterdam in 2025, and of course
What?
we're aiming for that. So
Really?
I'd probably be in the Movenpick also at that time.
Well, I do not envy you on that pressure. That's quite a thing.
We are aiming.
No, it's challenging. It's really challenging.
We are aiming to start construction in October.
Whoa.
The building itself will be finished around May, probably, and then we have around 9 months to house all the components, test it, and hand it over to the Port of Amsterdam. So it's quite a challenging timeline.
constraints in geography, people, planning, everything, the whole shebang.
It's all in, but
It's
to be honest, I think we are used to do big train and rail track how's it called, overhauls, which needs to be done in for instance 48 hours in the weekend. That's the total time slot you have. So
you can take your time for this one. Easy
Mike,
peasy.
Some of my colleagues say, "Well, it's going to be an easy job." No time pressure.
Good to hear. Well, I wrote down only a few questions. Now I got a whole page full. But first, Philip, maybe you would like to dive in and ask some questions.
Yeah, I would like to ask a question. Who is going to be the owner of the installation?
That is the passenger terminal itself. It's now called Cruise Terminal Amsterdam. They change names, but they will operate themselves. Yeah.
And the Cruise Terminal Amsterdam is part of the organization of the Port of Amsterdam. It's a 100% daughter organization.
And we will offer, or have offered, and we will take care of a certain period of maintenance, and during the first couple of years, it could be extended. It could be that the port takes over this activity. All kind of training programs for the personnel is included in the offer.
I have a question as well. So if I may, I'd like to ask a question. What's the building site? So where do you transport it from? And is it being transported over water, or are there other ways? So is there what's the location where everything will be transshipped and transferred from?
The building itself, it's about 30 meters wide, I think 12 meters in depth and 6 meters high. So it's quite a volume. We investigated to build parts of it prefab, and that's mainly the steel outer shell is prefabbed on a location nearby, and the inner buildings we just built it in situ. So those are made from building blocks. And at the other side of the I River, we have also a BAM office with a large workplace, so we can also build there and transport it by water. We have to figure out if that is, if that's profits, if we have some profit from that.
Yeah. Okay. Nice.
I have another question. Who's dealing with the vessel side of this project? Because with the installation, you don't have a reduction of CO2 if the vessels are not using it. So who's dealing with that part?
That's taken, the vessel itself, and whether or not to oblige them to make use of shore power is it's on the one hand in the EU regulation of course, but also that's taken care by the port itself. They are really keen on using the system. It's an ongoing discussion whether the cruise terminals should leave the city center. It was even in the news 2 days ago in the newspaper. So I'm really not that afraid that they would not push to the limit. And also the sector itself, they are really keen on use it. It will be their license to operate. The actual the cable management, we didn't discuss the cable management system in this presentation because that's Powercon scope. Of course, we're fully aware of what should be happen, but that is managed by them with our assistant to have the system, and it's also part of the training program. If that gives an answer on your question, Philip.
Well, partly because also active in shore power, and we try to make it an integral project with vessel users and location owners. so to really lower the emissions. Another question: in Hamburg, you have a project on the cruise terminal already since 2017. Why did it take until now that the port of Amsterdam, in this case, but many other ports are not have developed shore power earlier? What was the
Yeah.
biggest? What was the biggest hurdle? Maybe it's not the right person to ask to.
No,
It's up
well,
for discussion, right?
I have been in discussion with the Port of Amsterdam before I joined BA, and Vincent is aware of that. Maybe you too. I work for Siemens, so I'm in the development phase already 3 or 4 years. Yeah, to be honest and to be bold, it's all about the money. And the Port of Hamburg, they invested an enormous amount of money
Yeah, I know.
in this system. And I think that for now, with EU regulation and the techniques becoming more common, and yeah, it takes some time to convert all these ships.
Yes, well-known challenges there, I think. But
Many.
yeah, thanks. No other questions from my side for now.
Okay, thanks, Philip. Yeah, most of them are answered already, so that's good. So we're all a bit on the same page. Maybe a simple or a problematic question. How in God's name are you going to engineer on such quaysides? How do you sort of approach such a... Where do you start? Which quayside do you start?
Well, to be honest, the port already made a lot of investigation beforehand, so they have a lot of drawings. They made a preliminary design, so that helps us in starting up the project. We know what the port wants. They already contacted also the authorities, so for the permitting and the well stand and stuff like that. And we have several teams. Of course, a team for the civil part. We have a team for the electrotechnical part. And it's just a question. We need to have good insight, for example, in delivery times. So the transformers have a delivery time of about 14 or 16 months. So
yeah,
well, of course, we have to do that first. That's where we start.
Yeah.
But we have different teams working on it, and well, we separate it into different parts. So the quayside for all the cablings is a separate work package. All the primary installation are separate work packages. And of course, we have some partners. We are also engineering. So for ventilation and HVAC systems, we have another partner who is working on that.
Got it. Yeah.
So yeah.
But also imagine that be aware that this tender started
October
10 months ago.
Mm.
Around that, so we already did a lot of work which we had to hand over to the port authorities to make their decision on their preferred combination.
Yeah.
What is interesting here is that we have we start, of course, with the building. So it seems like we have a little bit more time for engineering the electrotechnical part, but the civil is we have so much interfacing with all the electrical components. So we are already starting our electrical engineering in detail, because our civil colleagues need to know the dimension of the components, the weight, etc. So
yeah. And it has to do with all the cabling and the routing, etc.
But also with sound level. If it turns out that we need another kind of switch gear, or maybe requirements from the port or the vessel owners, they change. We need to adjust the system. That could cause an additional couple of decibels. That means that we must take some additional measures on the building envelope, etc., etc.
Yeah.
But that's what we like to do, integrating projects.
Complexity.
This is really about managing the interfaces right now.
Yeah. And I saw that you have both 6.6 and 11 kV cabling, so you have sort of both options for cruise ships, or 6.6 for different seagoing cruise ships? Sort of, the vessels can choose?
Yeah, exactly. So in fact, we use the same cables for that. So we also use the same cable management. So they are connected to the same
Okay.
socket, same cable management system. And when we activate the system, we have to choose whether the ships need 6.6 or 11 kV or 50 or 60 hertz.
Yeah.
And then we switch on the system.
So that's all done by the flick of a switch, hopefully.
Yeah, exactly.
It's all done with an HMI of around this size.
Yeah, exactly. So one guy just pressing buttons, everything go.
Yeah, and to go a little bit more in depth, the output voltage is regulated by the inverters. So we have the normal output is, I think, 690 volt, which is step up to 11 kV with a step up transformer. Mm-hmm. If we need 6.6 kV, we just lower the output of the inverters. So we can use the same transformers for the whole system and the same cables and the same sockets.
Yeah, okay. Yeah, that makes it easier. And that's, of course, where the long lead times come from. These types of equipment, well, like you said, take 1.5 years to order. Is that already fixed then? Because it's, 1.5 years into the future. It's almost sail Amsterdam, so...
Yeah. We have some good relations with manufacturers. And normally, what we do is make a reservation for a slot in the production facility. So we say to them, well, the exact specifications you will get.
Yeah.
But please reserve some time in your factory to make a transformer with this amount of power.
Yeah.
And we will design it later on. But that way, we are making sure that we got the components in time.
Yeah, you have to, of course.
Yeah.
So just at the end of around August, September, then all main components will be ordered.
We've discussed vessels in detail, but what about the interfaces with buses, etc., and batteries? So that's a whole nother layer of complexity. It's not just vessels. If you want to power. Is there also interfacing with the trains? Can you use batteries maybe to sort of smooth or do some load leveling? How does the whole energy hub system work?
Yeah, that's all near future.
Okay.
So we prepare the system with some spare switchgear.
Yeah.
We have plenty of power available.
Yeah.
Even if there is a cruise vessel connected and 10 river cruises, there is still power available.
Cool.
But to be honest, that's the easy part.
You mean connecting the vessels, or?
No, that it's easier to connect an battery to the system, or a bus charger to the system. Have a proper connection with a cruise vessel, with all safety measures and synchronization and the 50-60 hertz conversion, etc.
Well, I think Philip, thanks for mentioning it. Maybe the five of us can speak for over 2 hours about this topic, but I think we're gonna. At least I can. I know for sure. But I think we're gonna summarize anyway. Last remarks, famous last remarks from Dick and Rick. Anything you want to close out with?
Yeah, I think mostly said. It's a really, really great project. I think it shows all the aspects of building a large shore power installation, like you said, in the city center of Amsterdam. It includes our civil part, the foundation, electrotechnical, the shore power installation itself, and it all comes together at, I think, 300 square meters. So that's really nice to see what's possible right now.
Cool.
Yeah, I fully agree with Rick. When it becomes difficult, then we start enjoying. So that's also from our, Rick mentioned already, from our civil colleagues, and I think the Port of Amsterdam, they made a wise decision to tender it such integrated, because all the interfacing That's gonna be a nightmare if you divide it in all separate.
Yeah, we have a lot of examples of that. That's for another. That's for another meeting.
Yes.
Yeah.
Well,
We
thanks for
can
your
also
time.
talk about hours about that.
Next time. Next time. Thanks for your time, gentlemen, and we'll speak to you soon.
Yeah.
All right.
Right.
Cheers.
Thank you for it.